Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled NGC 1514, the Crystal Ball Nebula. So what do we see here? Well, here we see an example of a planetary nebula known by its catalog designation of NGC 1514 or by its more common name of the Crystal Ball Nebula. Now, this is a planetary nebula, which, and despite its name, has nothing to do with planets, but is actually the end state of a star like our own sun. And this is what happens when a red giant star becomes larger and larger. Essentially, the core collapses down to something small, about the size of Earth, but still containing most of the mass of the star. The rest of the material expands outward and the star becomes a red giant and a red supergiant and maybe even a hypergiant, which in our solar system could fill big parts of the solar system out to Jupiter or even towards Saturn. And that would be how big the star would become. And as you might imagine, when the core is that small and dense and so far away from the outer layers, they're not very tightly held. And it doesn't take very much of an instability to push those out into space. And that's what happened here. Now, if we look at these, we see some very interesting patterns in them. In some planetary nebulae, it just looks like a puff of smoke going out. That material goes outward from the center. Here, there are some different sections to it, and that tells us that there's actually two stars there, not just a single star, but two stars in here, and that gives us some of the asymmetries that we see within the nebula. The two stars orbit each other with a period of about 9 years. So that can give these patterns as they whip around each other every few years, that the material that was being expelled out could have been expelled out more or less in one direction or another, as the stars constantly change positions relative to one another. So when we see planetary nebulae, we get a lot of different patterns that are visible, and often that is because of the exact nature of the stars at the center, the stars that once were the entire star and are now that compact remnant. And those are what then gives us the patterns that we see. So if there's more than one star, if there are 2 or 3 stars there, then that can give us completely different and more complex patterns. Other patterns can be because of the way we're observing them, and that means we could be looking at them from different angles. If they are not completely symmetric, depending on how we look at them, could affect how we see the patterns of material within a planetary nebula. Now, these might last 10,000 or 20,000 years and eventually will dissipate as they continue to expand, and the pressure from those stars will eventually cause the material to dissipate. In addition, as the star cools, it will no longer be energetic enough to excite the gases and cause them to glow. And this material will then just dissipate out into the interstellar medium, perhaps eventually becoming part of future stars. So some of the material we have here on Earth could have once been part of a planetary nebula billions of years ago. So that was our picture of the day, titled NGC 1514, the Crystal Ball Nebula. We'll be back again tomorrow for the next picture, previewed to be a fancy hat. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.